you are supposed to submit your proposal. And after all the lectures, you can start doing your presentation or report. So let's cut into the class itself. What's traffic simulation? Before I can answer this question, I want you to understand what computer simulation is. So what is computer simulation? Computer simulation is to use computer program to simulate an abstract model of a particular system. That's what is given online. But according to my own understanding, simulation is equal to creating your world in computer. And here, so the first important point of today, the terminology is here. Discrete or discrete event versus continuous. So when we are simulating a system, we can have two different views of the system. The first view is it's discrete. The second one is continuous. Let me give you an example. So when you are modeling, for example, you are modeling the movement of a vehicle. If you want to capture its attributes at any time point, then it's continuous. If you want to do it like per interval, like 1 step per second or 2 steps per second, then it's discrete. So discrete and continuous are based on how you look at your object. So if we talk about discrete event simulation, we have two types. The first type is called event-based. The second type is called time-based. So event-based simulation only recalculates the system status when a certain event happens. But for time-based simulation, you are recalculating the system status at every time step. And you probably will notice that time-based is also a category within event-based, because time-based actually only considers the event that the clock is ticking. Any question about that? Very simple. So now let's get back to traffic simulation. Traffic simulation has four key elements. First of all, it's trying to simulate the traffic system. Second, it's using computer. And it's dynamic, so it's considering the temporal dimension. And it has some visualization ability. And according to my previous definition, traffic simulation will be equal to creating your own traffic system in the computer. So to create a system, you first have to understand it. It's your comprehension of the system that decides how you model it. So the question is, how do people comprehend the traffic system? A natural way of simulating the traffic system is called microscopic model. In microscopic model, you are just replicating the discrete individual vehicles that you see on your daily basis. So in microscopic model, you are modeling every individual vehicle. And each vehicle is moving according to two sets of rules. The first set of rules is called car-following logic. And it's modeling the longitudinal behavior of vehicles. The second set is called lane changing. It's the lateral moving behavior. So this is the macroscopic model. Another type of model is called the macroscopic model. In this model, there is no individual traffic, no individual vehicle. All you see in your eyes are continuous traffic flows. So these were different things. And here comes the third one called mesoscopic models. In mesoscopic model, you see individual vehicles, but the individual vehicles are not moving according to any car following or lane changing logic. It can be described as macroscopic behavior plus microscopic entities. Or we can say we see continuous traffic flows carrying individual vehicles. So individual vehicles are moving like a boat on water. So the water is carrying the boat. So that's different model. So we have three types of models. Now I want to have a discussion here. Why do we need three types of models? For example, we have microscopic. Can we use microscopic models to produce the link flows? Of course we can. If we can count the number of cars, we get the volumes. So why do we need macroscopic model? There are basically two reasons. The first reason is the time to develop a microscopic model will be much longer than other models, developing other models, because you need more data. You need to specify more parameters. And another reason is that even making a model is easy, but validating is hard. You have to collect more data to validate your microscopic model than validating your macroscopic model. So these are the two reasons why we have different levels of models. And recently, I found that these macroscopic models are very popular. Here is a flow chart. So it's a very complex flow chart. This is the second important point of today. So let me explain it step by step. In the beginning of the simulation, we initialize the network, initialize the environment, and we calculate the shortest path for each vehicle. So each vehicle decides its routing, makes its routing decision. Then here comes the first thing, update control. Control here refers to traffic signal controllers. So we update signal control at every time step. Then we select entity. Entity means link or node. So we select one entity, and then we select one vehicle on the entity, and we update the vehicle using this car following or lane changing logic. Then we check if it's last vehicle. If not, then go back again. So this is a loop, the most inner loop. This is for selecting all vehicles on the entity. Then here it processes vehicles leaving entity, exiting the entity, like vehicles exiting a road. Then here's another loop, last entity. So in the second loop, it's selecting all the entities. Then it generates the arrivals, refresh graphical output, and update the clock. So time step +1. Then we come here to calculate new shortest path if needed. And then here comes the third loop, if the simulation is finished. If yes, and otherwise go back to here. So basically we see three loops here. This loop is time step loop. The second loop is for entity. The third loop is for vehicle. And this part is being executed for most times. This part. So we can evaluate the complexity of a simulation based on how many times you are executing this part. Any question?
What's the entity?
Entity means either a link or a node. Link is road. Node is like junctions or intersections. Okay? And if we can combine these two inner loops. This is select entity. This is select vehicle on entity. So if we combine these two loops, it will be selecting all vehicles in the network, on the network, right? So we basically have two loops, time step loop and all vehicles loop, right? So here I have a quiz for you. How are these factors affecting the total simulation time? If we have a model and we run it, what factors here are affecting the total simulation time? Let's take a look at size of the network. Does size of the network affect the simulation time? Yes, why? Actually, do you have an answer, Jay?
There's lots more entities to go through then.
Yes, there are more entities. You're right. But not exactly. So the size of network does not directly impact its simulation time, but it implies that when the size is growing, implies that the length or the average travel time is increased. So one vehicle may have to travel for longer distance. So one vehicle will exist in the network for a longer time. So this size of the network implies some, it's a factor of the simulation time. The second one is number of entities, including link and nodes. So let's consider we have a network with 1,000 links, but there's no vehicle running on it. So what's the simulation time? It will be 0. So number of entities does not affect this total travel time, the simulation time. And the number of signal controllers is the same thing. But if we take a look at the magnitude of travel demand, this will be an important factor. So the more vehicles you are having, the longer travel time, simulation time you're going to have. So when they are talking to you like, I have a model, I have 10,000 nodes, 10,000 links, don't be fooled by that. Just check how many vehicles they have. And the level of congestion is also affecting